guys? We're going to go over the action of different forces in three dimensional analysis in different supports. So we have 6 different supports, and we're going to start with the first one. So we have the member that is in contact with a smooth surface or ball supported member. So we have a smooth surface in their left hand side, which means there is no friction. So the member can easily move in X and Y direction. So in this scenario, we have the force normal to the surface and the direction will be toward the member, so we can call N, or we can call it Fz, and there is no forces in X and Y direction. Same for the other one, the ball supported member. Since there is no friction, the ball can freely move in X and Y direction, which there is no constraint. And same here, we will have only a normal force that would be normal to the surface and directed toward the member. The second we have is the member that is in contact with rough surface. So as opposed to previous one, we have friction here and there would be forces in X and Y direction. So the force in Z direction or normal force would be the same, but we also have the force of friction, which means we will have forces in X and Y direction. Let's move on to the third support, which is a roller or wheel support with lateral constraint. So in here, the roller can move freely in X direction. And since we are assuming there is no friction, we don't need to consider any force in X direction. However, the movement of the member is constrained in Y direction, which means we need to consider a force in Y direction, and we'll have the same normal force in Z direction. So we only have normal force and Fy. The fourth support that we have is ball and socket, which is very common in static problems. And in here, this time the member is supported in X and Y direction as well, which means we need to consider Fx, we need to consider Fy, and same for the Z direction, which will be again the normal force or Fz. And since the member can rotate freely about X, Y, and Z axis, we don't need to consider any moment for each of these axes. So we only have the forces which are free to pivot about the center of the ball support, and we only have force F, which has 3 components of X, Y, and Z. Let's move on to the fifth support, which is thrust bearing support. This is also very common support in static questions, and so as we can see, the member is constrained in each of X, Y, Z direction. So we need to consider Fx, we need to consider Fy, and we need to consider Fz as well. Now let's move on to the couples that this member can make. So as we can see, member can freely rotate about y-axis, which means we don't need to consider any couple in y-axis. However, we need to consider a moment in x-axis, and same, we need to consider a moment in z-axis as well. So the only reaction that we don't have is the couple about y-axis. And the last one is the fixed connection, which is either embedded or welded. So the member is constrained in any direction. So here we have our Fx, we have Fy, and we have Fz. And since the member is fixed at the since the member is fixed, we need to consider a couple about each axis. So we'll have mx, we'll have my, and we'll have mz as well. And we will have 6 unknowns in here, which means we need 6 equations to solve the unknowns in the question that we're given. So as long as the member is constrained with either the movement or the rotation or couple, we need to consider reactions for that specific support. When as long as there is no constraint, we don't need to consider any force or couple for that specific support. That would be pretty much everything for this video. We're gonna solve some problems in the future about these different supports in 3D questions, and I'll see you guys next time.